Hello students, let's solve the question. The question says that which of the following combination of statements is true regarding the interpretation of the atomic orbitals? So the statements are as follows. An electron in an orbital of high angular momentum stays away from the nucleus than an electron in the orbital of lower angular momentum. Now, one by one, we would be analyzing each of the statements. So statement A is saying that an electron in an orbital of high angular momentum stays away from the nucleus than the one in the lower angular momentum orbital. Yes. Now, if at all we go to put up the angular momentum of an electron, we go to indicate it, it would be by the equation of mvr is equal to nhi. Okay, so this is what? This is the angular momentum of an electron. Okay, to whichever shell it may belong to. Accordingly, we substitute the shell number over here, that is in the n value, and accordingly we can get it. Yes, so angular momentum of an electron. So n is what? N is the principal quantum number. So definitely this also implies one thing, and that is the angular momentum is directly proportional to the principal quantum number. Yes. So therefore, as the principal quantum number value would increase, distance of the electron from the nucleus will also increase, isn't it? Yes. Distance of the electron from the nucleus will increase. Yes. So which also means that as the electron moves away, the angular momentum will increase, isn't it? So thus, as the electron moves away from the nucleus, its angular momentum will increase. Yes. In short, what does it mean? It says that the first statement is absolutely true. Got the point? Yes. Since both of them are directly proportional, both of the values would increase or decrease with respect to each other. So that means A is totally correct. Yeah. So let us mark it as correct. Let us move on to the B statement. Now, what is the B statement saying? The B statement says that for a given value of the principal quantum number, which is n, the size of the orbit is inversely proportional to the azimuthal quantum number. Now, principal quantum number is n. Okay. What does it indicate? It indicates the shell number of an electron. Okay. And L, small l, is the azimuthal quantum number. What is it? Azimuthal quantum number. Yes. Okay. So accordingly, the statement which is saying that it is going to be inversely proportional and all, then we got to know one thing very well, is that the principal quantum number is absolutely independent of the azimuthal quantum number. Okay. So in no ways it is going to be inversely or directly proportional. Since it is independent, definitely there is no relation of the inverse relation. Yes. Therefore, in that case, we can say that the B statement is incorrect. Okay. Let us move on to C. C says that according to wave mechanics, the ground state angular momentum is equal to h upon 2 pi. Now, this is very, very basic. Yes. The C statement says that the angular momentum, as we had predicted in the first statement itself, is nh upon 2 pi. So ground state, which means if n is equal to 1, okay, if n is equal to 1, then definitely mvr will be equal to h upon 2 pi, isn't it? So that is definitely the ground state, isn't it? Right? So that means again the third statement is totally true. The ground state is equal to, the angular moment is equal to h upon 2 pi. Very true. Now let us analyze D. D says that the plot of psi versus r for various azimuthal quantum numbers shows peak shifting towards the higher r value. So peak shifting towards the higher r value. Okay. So let us analyze this statement now. So the D statement, it has indicated psi. Psi means what? It's the wave function or the probability of finding an electron. Yes. So the value of the peak of the plot for various azimuthal quantum numbers, yes, it increases in all directions. Okay. Value of the peak of the plot will always increase in all directions. Okay, in all directions with the value of n. Okay, with the value of n for various azimuthal quantum numbers. Okay, for various azimuthal quantum number. Okay, so in that case, there is no question that it is just shifting towards the higher r value. It is increasing in all the directions. Got the point? Okay, so therefore our fourth statement goes incorrect. Okay, so we have two statements which are correct, and that is A and C, and that has been given by option number 3. Okay, I hope you understood the explanation. Thank you.
Hello guys, in this question it is given that heat treatment for muscular pain involves radiation of wavelength of about 900 nanometer. Right? Which spectral line of hydrogen atom is suitable for this purpose? We have given some constant here, Rydberg constant, Planck constant, the speed of light is given here. We have 4 options here, Paschen, Lyman, Paschen and Balmer series. So let's start solving this. This question will be solved with the help of a very simple formula. The formula is 1 by lambda is equals to Rydberg constant into z square into 1 divided by n initial square minus 1 divided by n final square. So this is our formula. Here lambda is our wavelength, r is Rydberg constant, z is the atomic number, n1 is the n1 and n2, and final square is the number of orbit here. Right? So now let's start putting their value. We have wavelength is equals to 900 nanometers. So let's lambda is equals to 900 multiplied 10 to the power minus 9 here. We will convert into that meter only. So this is Rydberg constant. This is 10 to the power 5 centimeters. Inverse is given. So we will convert it into meter here. So this is 10 to the power 5. The centimeter is at the lower. So we have to divide it. So the centimeter will be converted into meter. So we will just multiply this by 100. So this, let me remove this as well. Here this is z square. Z is 1 for here because this is hydrogen atom. This is divided by here. This is 1 by n initial square. N initial is let's say n square here, right? Square minus the n final is our infinity, right? So this infinity square. This will be infinity square because in this series we have to find out this about series. So all the series in which the electron will be moved from infinite to some of this series, some of the orbital here 1, 2, 3 or 4, we have to find out its value, but the electron is coming from the infinite, right? So this is 0. If we solve this, this will be, this all zeros will cancel out. 10 to the power 5, this 10 to the power 7 only, this is 7, add on this side, this will be 10 to the power 7, so this is same as it is. So n square is equals to 9 here, n will be equals to plus 3. So here we got n will be plus 3. So which means this is a in this type of question, in this question, this electron is coming from infinity to n is equals to 3 here. So this is a type of series which is named as past chain. So here this is past chain is of two types. In two options this is past chain given, which means option number B and D will be correct. But here this is saying that n is equals to 3 and it is coming from infinity. So the only option which is infinity to 3 is this is correct, this is wrong. So option number A is correct answer. This is answer. Thank you for watching. Best of luck and bye bye.